Our lesson today is to be able to graph and describe reflections. First, a reflection is a transformation that flips a figure over a line of reflection. A line of reflection is a line across which a figure is reflected. All right, let's take a look at what we have here. So our first example here, start with my good pen. It says graph the point A at 3, 2, then graph its image after it's reflected over the x-axis. Name the coordinates of point A, or A prime, its image. So the pre-image A is located at 3, 2. So over 3, up 2, we put a point, we label it A. There's our pre-image. We want to graph its reflection over the x-axis. Well, my x-axis here is the horizontal number line. When we draw a reflection, we simply find that line of reflection, which here is the x-axis, and we go the same distance from that line of reflection, but in the opposite direction. All right, and there's my A prime. We use the prime notation to denote that it is an image, not the original. To name the coordinates of A prime, we then see that A prime is located at 3, -2. 3, -2. Now, one of the things I'd like for you to notice is that point A was located at 3, 2. A prime was located at 3, -2. So we see that when we have a reflection over the x-axis, the x value stays the same, but the y value becomes its opposite. All right. Let's see. Now, let's take A prime and reflect A prime over the line through -4, 0 and -4, 5. So let's start with that. Let's draw the line through -4, 0. Here's -4, 0. And where's -4, 5? Here's -4, 1, 2, 3, 4, 5. And we want to draw a line, right? We want to draw a line through this point. But let's make that line, let's make it red so we could see it a bit. All right, good. All right, not too thick. Good. All right, so let's draw a line here. Okay, so there's our line. We want to take A prime and reflect it over that line. So once again, when we draw a reflection, same distance from the line of reflection, but we want to go opposite direction. So we are 1, 2, 3, 4, 5, 6. A prime is 7 units away from our line of reflection. So we count 1, 2, 3, 4, 5, 6, 7 units away in the opposite direction. And we're going to call that a double prime because that is our second image. All right? Okay, let's try another one. Graph the point -4, 3, then graph its image after it's reflected over the x-axis. Name the coordinates of C prime. Then we want to take C prime and reflect it over the y-axis. Name the coordinates of C double prime. Okay, let's do this one step at a time. Let's graph point C at -4, 3. So here's -4, 3, right? That's point C, right? And that's it. -4, 3. We want to then graph its image after it's reflected over the x-axis. Once again, here's my x-axis. It's the horizontal number line. So I want to take point C and go the same distance, opposite direction, and we're going to call that C prime. All right, and once again, notice that when we have an x-axis reflection, the x value stays the same, right? We're still -4, right, from 0 on the x-axis. But the y value becomes its opposite. Instead of being at +3, we're now at -4, 3. So that would be the location of C prime. But let's see what happens when we take C prime and reflect it over the y-axis. Well, my y-axis is the vertical number line, right? So there's my y-axis. I am 4 units away from the y-axis. So I want to go 4 units away, opposite direction. We're going to call that C double prime. What's the location of C double prime? Well, that's 4, -3. That's a +4 on the x-axis, -3 on the y-axis. So notice, when we have a reflection over the y-axis, the y value stays the same. X value becomes its opposite. All right? And that's kind of summarized on the next page here with our rule. When we reflect in the x-axis, x comma y goes to x and opposite of y. So reflection in the x-axis, x value stays the same, y value becomes its opposite. When we have a reflection in the y-axis, x comma y goes to the opposite of x, y value stays the same. All right? So let's play around, do some more examples, because there are a lot of other things we do with reflections. All right, let's try a triangle here. It says the graph triangle ABC with vertices at 1, 2, 1, 0, and 6, 0, and its reflection over the y-axis. What are the coordinates of A prime, B prime, and C prime? Well, let's start with the rule, right? Because we just said that when we have a reflection over the y-axis, right, that the y value stays the same, but the x value becomes its opposite. So the y value stays the same, x value becomes its opposite. 1, 2, x value becomes its opposite. That's going to be -1. Y value stays the same. All right, B prime. Reflection in the y-axis. Y value stays the same. X value becomes its opposite. We go from 1 to -1. For C prime, y value is going to stay the same, right? But the x value becomes its opposite. So we can actually come up with the coordinates of the reflected triangle, of the reflected figure, without actually graphing the figure. But let's graph it because we are asked to graph it. So let's graph triangle ABC, and let's see what this reflection is going to look like. All right, I'll do it in blue. We have A is at 1, 2. All right, there's point A. Point B is at 1, 0. Here's 1, 0. And point C is at 6, 0. 2, 4, 6, 0. So there's C, and there's B. All right, and that's a triangle. So let's draw our triangle here. All right, make that blue. And we're going to go here, here, and here. All right, but I got to straighten out that other segment a bit. It's just a little crooked. Oops. All right, better. Okay, and now we want to reflect it, let's see, over the y-axis. Well, here's my y-axis. All right, so same distance, opposite direction. All right, it's going to be A prime. I take point B, same distance, opposite direction. It's going to be B prime. All right, point C is, let's see, 2, 4, 6 units away from the y-axis. So we go 2, 4, 6 units away from the y-axis, and we get C prime. All right, let's connect our points here. Go here, and we go here. Now, one of the things we really want to pay attention to is the fact that reflected figures are congruent, right? If you graph your figures after your ordered pairs and you see that the figures are not congruent, you made either a mistake with your math or graphing your ordered pairs, right? But we should see, and I didn't write my C prime here, right? We should see that these figures are congruent, all right? Meaning they are the same shape and the same size, all right? Let's see. Let's go on to our next example. We want to graph triangle BCD and its image after it's reflected over the line through 1, 3 and 1, 0. Name the coordinates of the vertices of B prime, C prime, and D prime. All right, so let's graph triangle BCD. B is located at -3, 4, so here's -3, up 4. There's point B. C is located at -1, 0, so here's point C at -1, 0. And point D is at -3, 0, right? There's point D. All right, let's graph. All right, connect those points here, right? And we get something like this. All right, that looks good. Now, we're asked to reflect it over the line through 1, 3 and 1, 0. So let's draw that line at 1, 3. Here's 1, 3, and here's 1, 0. So the line drawn through these points, this is going to be my line of reflection, right? So I want to draw the line through those points. So my line of reflection is here, right? It's not the y-axis, right? It's one space away from the y-axis. So if this is my line of reflection, we take one point at a time. I go same distance, so point C is 2 units away from my line of reflection. I go opposite direction. There's my C prime. Let's do point D, where or point B, I'm sorry. 1, 2, 3, 4 units away from my line of reflection. I go 4 units opposite direction. There's my B prime. Point D is also 4 units away. So I go 4 units away in the opposite direction. There is my D prime. Right? We connect those points, and the importance of connecting the points is to see that your figures are congruent. Right? You want these figures to look exactly, right, the same, right? So they have to be congruent. All right. It does ask us for the coordinates, so let's name our coordinates. All right. C prime is located at what? 1, 2, 3. So C prime is at 3, 0. Point D is at, D prime is at 5, 0. And where's point B prime? It's at 1, 2, 3, 4, 5. 1, 2, 3, 4. All right. So B prime is located at 5, 4. All right. All right. So far, so good. Let's try a couple more. All right. Here it says triangle F, or what's that? EFG has vertices at 4, 3, 3, 1, and 1, 2. Graph triangle EFG and its image after a reflection over each line. Name the coordinates of the vertices of the reflected triangle. All right. So it looks like we're just going to reflect it over the line through those 2 points. So let's start with the triangle first. All right. We can't use a rule because we're not reflecting over the x-axis or the y-axis or even the line y is equal to x, which we're going to look at a little bit later, where you can also use a rule. So here we actually have to start by graphing the triangle. So point E is at 4, 3, over 4, up 3, put a point. It's going to be E. Point F is at 3, 1. Right? It's going to be point F. And G is at 1, 2. Right? There's my point G. Let's connect our points here. All right. So we go here, and we go here. Now we want to reflect this triangle, right, over the line through -2, 4. Here's -2, 4, and -2, 0. So the line drawn through those points will be our line of reflection, right? So there it is. Let's draw our line of reflection. And now we take each point one at a time, and we go the same distance from our line of reflection, but in the opposite direction. So if I start with point G, I'm 3 units away. So I go 1, 2, 3 units away in the opposite direction. It's going to be my G prime. Point E is 2, 4, 6 units away. So I go 2, 4, 6 units away from my line of reflection. It's going to be E prime. All right, F is, let's see, 2, 4, 5 units away. 2, 4, 5 units away from my line of reflection. There's my F prime. I want to draw my triangle to make sure that, we have a similar figure. All right, or congruent figure, I'm sorry. All right, it has to be the same, exact size, and same shape, right, for congruency. All right, and it says for us, or asks us to name the coordinates of the vertices of the reflected triangle. So let's go with E prime. E prime is located where? 1, 2, 3, 4, 5, 6, 7, 8, 3. -8, sorry, right? -8, 3. F is located at 2, 4, 6, right? -7, 1. And G prime is located where? Let's see, 2, 4, 5, -5, 2. All right. And then we have our coordinates. All right. All right, let's try, this next one, same one over the x-axis, but that's a little bit easier. because take the same triangle and we can reflect it over the x-axis. Let's use the math to do that, right? Because we know we can use a rule to reflect over the x-axis, right? So I'm not even going to draw this one, all right? It says name the coordinates, right? It does say graph, but we'll name the coordinates. So reflection over the x-axis, we know the x value stays the same, y value becomes its opposite. So E prime, x value stays the same, y value becomes its opposite. So 4 comma 3 becomes 4 comma negative 3. F prime, a reflection over the x-axis, all right? X value stays the same, y value becomes its opposite. That's going to be 3 comma negative 1. And then we have G prime, x value stays the same, y value becomes its opposite. So that looks like that should be our ordered pairs, all right? So let's start with the first triangle. Let's graph it and see what it looks like. 4 comma 3, 2, 4, up 3. That's point E. F is 3 comma 1, right? There's our F. And G is at 1 comma 2, right? There's our G. All right, I'll try to be neat. All right, that looks pretty good. And then we have E prime, F prime, G prime, reflection over the x-axis. So here's my x-axis, but let's see. Let's use our ordered pairs. We have 4 comma negative 3. That's our E prime. Then we have 3 comma negative 1. That's our F prime. And then we have 1 and negative 2. That's our G prime. Connect our points. Right, and we should have congruent figures, right? And they look good. And we have a nice clean reflection over the x-axis. All right, same figure, but now we want to reflect it over the line y is equal to x. Well, the line for y is equal to x, right? We know that the slope is going to be what? Positive 1x. Let's do that real quick. Positive 1 and the y-intercept is 0. So if we were graphing the line of y is equal to x, we'd have a point at the origin at 0 because the y-intercept is 0. Then we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So there's the line for y is equal to x. All right, that's my line. And we know that that line goes on forever. But we're going to draw a reflection over that line using a rule. All right, well, let's start with the first triangle. So we have 4 comma 3 over 4 up 3. Right, that's our E. We have F is 3 comma 1. There's our F, and we have G is 1 comma 2. Over 1 up 2. There's G, 1 comma 2. Connect our points. Good. Now, a reflection over the line y is equal to x. Because y is the same as x, we just reversed the ordered pairs. So E prime, a reflection over the line y is equal to x, the y value becomes x, the x value becomes y, so 4 comma 3 becomes 3 comma 4. F prime, 3 comma 1 becomes 1 comma 3, and for G prime, 1 comma 2 becomes 2 comma 1. Right, so it's just a rule that if we have a reflection over the line y is equal to x, because y is the same as x, we just simply reverse or flip-flop our x and y values. So let's see if that looks like a reflection over the line, where each point is the same distance, opposite direction. So we go 3 comma 4, and that's going to be E prime, right? And that looks pretty good, right? Same distance from the line of reflection, opposite direction. 1 comma 3. 1 comma 3 is going to be our F prime. That looks good, same distance, opposite direction. And then G prime is at 2 comma 1. Right, there's our G prime, same distance, opposite direction. Right, those triangles should be congruent. Right, if we connect our points kind of neatly, right, that looks good. Right, so just remember, a reflection over the line y is equal to x, we simply flip-flop, or y becomes x and x becomes y. All right, and let's see, is there anything else that we need to do? Let's see. Graph the triangle and its reflection over the line that passes through that point. What are the coordinates? That's one that you guys could probably play around with on your own. All right, let's see, is there any other, was that it? Oh, let's see what we have here. Let's see, triangle XYZ is vertices of that. Reflect a triangle over the line y is equal to x with the coordinates of, then reflect, let's do this, right? This is kind of a little tricky. Let's try this one. Triangle XYZ has vertices of 2, 1, 5, 1, and 5, 5. So let's try that. 2, 1 over 2 of 1, that's x. Y is at 5, 1, there's y. And we have z at 5, 5. There's 5. 2, 4, there's z, 5, 5. All right, there's your z. All right, let's connect those points. Try to make this one a little neater. I want to be a little bit more precise here. It's going to be blue. All right, so it's going to go here, and then here, and here. Okay. Now, we want to reflect that first over the line y is equal to x. So we just did a problem where we know that the y value becomes our x value becomes y value, right? So let's do this in a different color. So we have x prime, right? X prime, we flip-flop x and y, that becomes 1, 2 for x prime, right? 2, 1 becomes 1, 2. Y prime, let's see, 5, 1 will become 1, 5. And z prime, let's see, 5, 5 becomes 5, 5, so that doesn't change a bit. All right, now we didn't draw our line of reflection yet, so let's draw our line of reflection. Probably should have used a different color there, but we should go up 1 over 1, up 1 over 1. Let's say up 1 over 1, up 1 over 1, up 1. I want to make sure a little bit more precise. Okay. Let's change the color a bit because that could be a little distracting. So let's make that, I don't know, make it red so it stands out a bit better. Okay, so there's our line of reflection. All right, now we know that we have our ordered pair, so 1, 2, that's x prime. Let's do this different color though. Let's undo that. All right, let's do this in green. Right, so 1, 2 over 1 up, 2. That's going to be our x prime. We have y prime, which is 1, 5 over 1 up 5. It's going to be our y prime, and our z prime is 5, 5. So they actually share the same point. All right, I should have tried to be a little neater. Let's see if I can fix that a bit. Cheat and move this a little bit. No. That's all about it. Good. Okay. Got to be precise with these drawings sometimes. Let's connect the dots here. All right. Connect our points. Okay, good. That looks like a nice reflection. All right. They look congruent. That looks good. But now we want to then reflect x prime, y prime, z prime over the y-axis and give the coordinates of x double prime, y double prime, z double prime. Now we could have done this without graphing because we know that a reflection over the y-axis, y value stays the same, x becomes its opposite. So x double prime will look like what? X value stays the same, no, we're reflecting over which one? Y-axis, correct? So the y value stays the same, x value becomes its opposite, so 1, 2 becomes negative 1, 2. Y value stays the same, x value becomes its opposite. Y double prime, y value stays the same, x value becomes its opposite, negative 1, 5. And for z double prime, y value stays the same, right? X value becomes its opposite, so negative 5, 5. Let's graph those ordered pairs, right, and see the reflection over the y-axis. So we have negative 1, 2, that's x double prime. Then we have negative 1 and 5, negative 1 up 5. There's our y double prime, and z double prime would be negative 5 and negative 5, right? That looks good. Negative 5, that's my z double prime. Connect our points, right? That is my reflection over the x-axis after reflection over the line y is equal to x. All right, so those are some pretty good examples of what we're trying to do with the reflections, right? We can use rules when we have reflections over the x-axis, when we have reflections over the y-axis, and we can use a rule for reflection over the line y is equal to x. All right, when we have a reflection over the x-axis, remember x value stays the same, y value becomes its opposite. Remember that when we have a reflection over the y-axis, y value stays the same, x becomes its opposite, and when we have a reflection over the line y is equal to x, we simply switch our x values and y values, so our y value becomes x values become y values. All right, I hope that that's been helpful, and we'll see you soon.